I'm Jessica.
I'm Paige.
And this is our physics project.
The most humorous thing that happened in physics has to be when Jessica and I were making those balloon cars with the candy, the straws, the paper clips, and the balloon. Well, the whole class was taking a test, and Jessica and I had to leave early for a softball game, like always. And so we were blowing up the balloon
in the back room of Miss Trione's class,
and the balloon was making really loud, weird noises, if you know what I mean.
So yeah,
we're trying not to laugh. Okay.
The most amazing thing I've learned, probably vectors, because vectors are just like, they're just so interesting, and like how they, how you add them like head to tail is just like mind blowing, dude.
Trione.
So next year in class, I'll be like, it'll be all quiet, right? And then my phone will probably ring, and I'll be like, oh, 1 second. I'll be like, wow, radiant energy.
And this is radiant energy because the cell phone towers,
not towels,
send enough radiant energy to our cell phones.
Yeah.
So I have some advice for you next year, sophomore, juniors, or seniors. You're going to take Miss Trione's class. Tell her you have a joint problem, or else you're screwed.
So for the rest of my life, every time I walk into a pole or a wall or some kind of object, I'll be like, whoa, Newton's first law. You know, wait, what's Newton's first law? Hold up. An object will stay at rest or at a constant velocity until an unbalanced force acts on it. So, if I'm the object and the wall, the unbalanced force, I'll be like in motion and then like not be in motion because I ran into the wall.
So I'm here to talk about potential energy. Right now I'm holding a pair of sunglasses, and this is potential energy because if my hand wasn't here, it'd fall to the floor. Yeah. So right now I'm in kinetic energy. I'm doing kinetic energy because I'm... So kids, we're here to talk about projectiles today. Oh, free fall. So a free fall, when an object is in free fall, it moves in a parabola, not in a straight line. So let's take Jessica's step. Okay. Alright. Okay, 1, 2, 3. Free fall. So
don't do this at home, by the way.
Yeah. Okay. So Jessica's cat didn't just move from one place to the other. She started on the ground, came up, reached her maximum displacement, and came back down in a parabola.
Waves are an interference that carries energy through matter or space.
So the first kind of wave we are going to talk about today is electromagnetic waves. And these are waves that can travel through a vacuum or outer space. Did you know that, Jessica?
Now I do.
So these waves, such as visible light, microwaves,
etc., etc.,
they can travel through outer space. So the next type of wave brings us back to mechanical waves. And these are waves that cannot travel through a vacuum or outer space. So you need a medium or a material to travel through. So these, such as sound waves, ocean waves, or any kind of waves, like I can make a wave out of this. Woo! Wave! And
Hand wave.
they need a material to travel through. So our next topic is circular motion. I'm here to talk about circular motion, as you can tell from the poster. When a continuous force is acting upon an object, pointed towards a certain point, it will cause an object to move in circular motion. So the force that is causing the object to move in circular motion is the centripetal force, meaning center, which is located in the center of the object in circular motion. From the centripetal force to the outside of the circle is the radius. Okay, so there's a force on an object on the outer part of the circular motion, which is the tendency to want to move in a straight line. So if the centripetal force were to stop, the object would move at a tangent, meaning straight line, same velocity, or same speed. There we go, kids. Okay, that's circular motion.
So what you're asking is, what is electricity? So if I were to have this hat on, and I'm like, woo! So it's like taking off all the electrons.
The balloon touched the hair lab.
Yeah. You remember that? Okay, so if I take this off, my hair's all like, okay, well usually it'd be static. But I mean, my hair is so perfect it doesn't get static. Oh. It's like, oh my god! Is the hat takes off all the electrons, so then, all my hair particles are positive, and positives, like, they'll repel each other, because, I mean, they're the same charge, so they'll be like, ah! So they'll all, like, spread out, and, like, make my hair,
because positive attracts to negative.
But then positives will be like, no. So Paige and I are sorry to say that this is the end of our 2% extra credit physics final project. See you next year.
Have a wonderful Thursday, Fremont.
Nay! No.